Good afternoon, everybody. Welcome. My name is Selim Tezel. I'm one of the members of the education team of MIT App Inventor. With my colleague, Evan Patton from the dev team, we're going to be giving you an overview of App Inventor project and also at the end, answering your questions. Now, in the event that you would like to be able to follow the slides, we have a bit.ly address that I have here on the screen. And my colleague, Robert, is going to put it up a little bit later again on the chat if you haven't already caught that. But there are a lot of links and video links and audio links, etc. In the presentation. We're not going to get to each and every one of them, but at your leisure, you could go through that. So we are the MIT App Inventor team. We're changing the world one app at a time. Now, our story starts in 2007 with our PI, Hal Abelson's sabbatical at Google. He has joined us, and during the Q&A, you should definitely get the full scoop on the story. But from what I understand, he basically, during the sabbatical, wanted to come up with some ideas to make mobile app development more accessible to people, to democratize that environment. And at the time, Scratch was becoming very popular. So I believe he was also inspired by Scratch. And he was able to gather some software engineers at Google, like Mark Friedman and a company, and they were able to start this project. And within a few years, the project moved to MIT. And currently, we have a fairly large group. We are about 11 staff members, some admins, some dev team, some ed team, education team. We have currently one PhD student, a number of MN students, and quite a few Europes. And we have quite a few advisors who are either past, colleagues of ours or colleagues from different projects. Now, what I would like to quickly do is so we'd like to give you a sense of the App Inventor coding environment. As you can see here, it's a completely visual environment where both the design of the user interface and also the coding with blocks are done completely visually. And what I would like to do is I'm going to quickly show a video, and I hope the sound for this is good, in which my colleague Evan demonstrates how to use App Inventor interface.
Here's the App Inventor user interface. In the middle is an example of what the screen will look like as you edit it, and for demo purposes I'm showing the emulator in the middle as well. You can drag components from the left side of the screen to add them to your application. We're going to build a very simple translation app using text-to-speech and Yandex Translate. And any component in your application is fairly customizable. You can change properties by selecting the component and then editing the property in the right column here. Behavior of the app is done by using a block-based programming language. There are event handlers for the different components. So when I click on a button, I want to translate the text of my app. And I'm going to grab the text from the text box. And for demo purposes, let's translate it into Spanish. And when I get my translation back, I want to use the text-to-speech component to speak the translation back to the user. And now in my emulator, I can type "Good afternoon," and we get the translated speech back.
Buenas tardes.
Alrighty. I can't tell if the sound for that was reasonable. Were you able to hear, Evan?
Yeah, it sounded like it came through okay, although people may need to adjust their volume a little bit to hear it.
Okay. We also have on the slides another demo, which is a little bit longer, 7.5 minutes, which sort of talks about, how would you have a password protection in an app, etc. So moving forward, Evan, do you want to start talking a little bit about the technical aspects of App Inventor?
Absolutely, Salim. So for those of you who have been following App Inventor for a while, you know that App Inventor started on Android back at Google and has that's been the case since then. Just this year, starting in March, we also have a version of App Inventor that is available for people to use on iOS. So the really amazing thing about this, because of the underlying nature of our intermediate language, which is based on Scheme, is that you can have the same program built in App Inventor that targets both platforms, both Android and iOS. And our aim has really been to make sure that there are no changes needed between the two platforms. And the goal here is that, if you're a teacher and you've got students in the classroom, some students have Android, some students have iOS, you don't want to have two separate curricula to deal with that. You just want to be able to make it so that both sets of students are able to have the same experience working together. Next slide, please, Slim. So running App Inventor is actually a really big, big project, and most of that weight actually falls on Jeff's shoulders. And you're welcome, Jeff, to maybe chime in here if you want. But we have a number of servers that are run throughout the world. The main instance of App Inventor runs out of Ohio and Google's App Engine. We also have another set of systems that are based out of North Virginia and Washington, D.C. And then we have our build server infrastructure based here in Cambridge at MIT, although occasionally we need to move these things around based on the availability of various resources. And one of our major projects, which Salim will cover a little bit later, is based in Hong Kong. So we do have some services running out of Singapore for geographic proximity, as well as Hong Kong. And so really App Inventor is a worldwide project. We never necessarily sleep. Salim, next slide. So App Inventor itself is huge when it comes down to it. We have almost 15 million registered users in App Inventor, and they've created amongst themselves 66 million projects and change. And every country on the world almost uses App Inventor. And just recently, actually, the US was the biggest country by users in the world up until this year. I think the coronavirus pandemic has kind of something to do with this because we saw a significant drop off in the US, but not in Taiwan, where things were handled a little bit better. So now today, Taiwan in the last year has made up about 13.8% of our user base, whereas the US makes up 13.3%. And you can see kind of the top 10 countries there by usage. But really it's a worldwide phenomenon at this point. And on any given month, we have about 1 million active monthly users. And I haven't checked the numbers today, but these numbers were updated as of 2 days ago, but we had 80,000 users a day as of Monday. So it's quite a popular platform. Next slide. And all of this, I mean, it really is kind of capturing people's imagination. So earlier this year, we were named one of the top 40 edtech platforms in the world based on this company, EdTech Insights. And obviously you got top contenders like Google Docs and YouTube and all these various education resources used throughout the world. But and we happen to be number 37. But it really goes to show just how many people out there are relying on App Inventor to learn about the core essentials of computer science and computational thinking, computational action. And you can read more. I think we have a link in here, but if not, we can go back and add it. But it's really a wonderful opportunity for us to be able to bring this to everybody. Next slide. And that is kind of reflected in our community as well. So you're welcome to join us. We have community.appinventor.edu here. We have thousands of people contributing ideas there and helping one another. And App Inventor is also open source. So in addition, you can hop on GitHub and you can grab the App Inventor sources and build your own copy. We've had over 150 different people contribute to App Inventor over the years, and they've contributed over 2,500 different commits and changes to the system. And that's an ongoing thing. So these numbers are not even correct as of earlier today because we merged a whole bunch of stuff. So it's really a wonderful and alive platform for people to contribute to. Next slide.
All righty. Thank you, Evan. Thank you. So I want to quickly talk about our mission, and this is sort of inspired by Hal Abelson at his time from Google. The first mission statement we have is democratization of the app development environment. Historically, app development was in the jurisdiction of very talented, highly educated, folks with a lot of software engineering background. But with platforms such as App Inventor, it is beginning to be accessible to even very young children. Our second statement is creating tools that positively change young people's perception of themselves. What do we mean by that? For example, the coronavirus pandemic is an example. When the pandemic hit the world, people found themselves in a very helpless situation. Schools were closed, people were locked into their houses. So especially for young people, it was important that they sort of move away from the sense of helplessness, inefficacy, to some sense of empowerment. And also in the process, sort of move from a consumer mentality to beginning to feel like a creator. Especially during this time where we see and hear a lot of social media, environments, damaging sense of identity for young children. It is very gratifying to be part of a project where these tools are positively changing people's perception of themselves. Finally, a logical conclusion of all of these is promoting computational action. And by that, what we mean is, using the power of computing to make meaningful social impact. So young people are beginning to use, their apps to have some impact on their societies. Now, I'd like to give a few examples of these, examples of computational action. Some of these are very famous. They were in MIT News like a few years ago. So the first project I would like to talk about very quickly is Dharavi Girls. This is, so there's a slum in Mumbai, India. And in 2014, a nonprofit was founded with the hope of teaching young girls, how to make apps. And the girls created apps for all kinds of, community, projects, garbage collection, learning subject matters like math, English, Hindi, apps for, women's safety, coordinating water collection, etc. The project was incredibly successful, and Google awarded the project with the Rise Award. Another project from Los Fresnos, Texas, is from a middle school, 6 girls in the school. They had a blind classmates who were having very difficult time navigating the school environment. So they built a navigation app to help the student. And they participated in the Verizon Innovative App Challenge and won an award. And in 2014, you can see here, they met President Obama at the White House at a science fair. The next project is Dementia Care Companion from Hong Kong. These young students won the 2017 Technovation Grand Prize. Their app basically had all kinds of features, like alarms, locator functions, tips for caregivers, games, humanized messages from family members, etc. It was a fantastic project. Now, our possibly the most famous of our community members, young community members, is Gitanjali Rao that you can see here. You may recognize her from last year. She became Time's first Kid of the Year at the age of 15. Her career started a few years before that when she was passionate about addressing Flint's lead poisoning disaster. So she, devised some gadgets using nanotubes, etc., that help, measure the lead level in water. But then with the help of App Inventor, was able to communicate that data, into a mobile phone and make that very accessible. Now, all these projects, inspire us in many ways, and one of the ways it has inspired us is to come up with a book. Last year, you may remember my colleague Karen Lang and we worked on a book, and the book, has just the regular, technical aspects. How do you build a game? How do you build a musical app, etc. But at the end of every such chapter, we try to enrich the book by putting a human story. There will be a story from one of these projects, how did App Inventor inspire these people to get into the world of technology, and how it was able to shape their future careers. Gitanjali Rao, who I just mentioned, was kind enough to write the foreword, and it was a very interesting experience for us. Now, our inspiration also comes from our many collaborations. So I'm just going to mention some of our bigger collaborations here. The first one is YR Media, formerly known as Youth Radio. Basically, the NSF grant for the first phase of our collaboration, the idea was basically this. It was called Youth Mobile Power Series. Our colleagues at Youth Radio, young people basically, they would write a story, a human interest story. Like in this case, one of the writers wrote about, what is it like to be a translator for an immigrant family. And the App Inventor team's job was to come up with a app idea, a tutorial for an app idea that complements that story. So we had very similar to what Evan showed you, a translation app that goes with that project. And we had many, stories and apps that went together in the first phase. In the second phase of our project, we are in this phase called Outsmarting AI series. And here it's very similar. There will be a story written by the YR Media folks. In this case, there was an article called, Could Your Next Therapist Be Your Phone? And we were inspired by MIT professor Weisselbaum's ELIZA project. And we basically created a rule-based AI app that sort of, plays the role of the therapist in a non-directive therapy session. But we also have some machine learning-based AI projects. The YR folks wrote a article called "Can You Teach AI to Dance?" And we used the PoseNet interface to track the human body, and the tutorial basically taught people how to create an app that uses this information to quantify some dance moves, etc. One of our bigger projects is with Cool Think, which is sponsored by Hong Kong Jockey Club Charities Trust in Hong Kong. We create, a curriculum for grades 4, 5, and 6. The first grade, the fourth grade is our Scratch projects, and 5 and 6, the kids sort of move on to App Inventor and create a lot of projects. Currently, Cool Think is in 32 network schools serving about 21,000 students, and we have trained 112 teachers currently. But the plan is to ambitiously expand this fivefold to 150 schools, which is about 40% of the schools in Hong Kong. We collaborate with Education University of Hong Kong. And just like a month ago, the project was awarded by ISTE the Seal of Alignment. And here you can see some visuals of some of the projects. On the left, we have some computational, mathematical art projects in Scratch for grade 4. And then in grades 5 and 6, you have some, musical projects, game projects, projects that use maps like tour guide projects, games, etc. One of our most recent collaborations is with Amazon Alexa. Our PhD student, Jess, a number of years ago, figured out how to use the App Inventor interface to communicate with the Alexa interface and have some Alexa skills develop. And what happened is, this really made that whole process very easy, and integrating it with the mobile app environment. And we are in the middle of some very exciting projects. Amazon heard of Jess's progress and wants to work with us to extend this into some interesting areas. You may have also heard that we are part of the RAISE initiative. RAISE is Responsible AI for Social Empowerment and Education. There are several groups from Media Lab, etc., that create this group. We announced last week the inaugural Day of AI, which is going to be on May 13th, 2022. And it is inspired by Hour of Code, but instead of just an hour of coding, these events are spread to at least a week, possibly, at least a day, possibly up to a week. And we are in the process of recruiting teachers for this. Now, we also collaborate with what is called the AP Mobile CSP group. This is basically a college board accredited group whose curriculum is entirely based on App Inventor. So all of the projects, etc., happen in App Inventor. And since its inception, we have reached to 47,000 plus students and about 2,600 plus teachers. And there's some very interesting statistics that show how the mobile CSP, results, performance-wise, etc., are significantly above the national average for other AP projects. Finally, I want to mention Technovation for Girls. You may have heard of this project. It's a way of getting girls all over the world excited about programming. App Inventor is one of the main, if not the main, programming platform. And I mentioned Karen Lang earlier. She's a dear colleague who left our team, and she's currently working there. And we are in great communication and collaboration with her and her team. Okay, Evan, if you don't mind, I want to switch it back to you so you could tell us a little bit about some of our other activities and competitions, etc.
Thanks, Liam. So all of the projects we've recently talked about here kind of come to what we call this idea of computational action. It's not just thinking about computing and what computing does for us, but how can we apply it in the real world? And this really came to a head this last year, as we all know, in the coronavirus pandemic. And a lot of our summer plans were upended, unfortunately, last year. And what we did instead is we ran a coronavirus app challenge as well as an appathon. And the goal here was to really encourage folks to build really interesting apps around dealing with this coronavirus pandemic. And you can see here on the slide some of the winners of that competition, but some great ideas from kids and adults alike about how to address some of the issues that were raised up by the pandemic. And then next slide, Slim. So this year we revisited it, hoping, of course, that we wouldn't have to, that we could be in person together again. But we created the App Inventor Appathon 2021. Appathon for Good, and we had three main themes around that, including City of the Future. So what might an app for the City of the Future look like? Apps to help students improve their academics and to help their communities, kind of in line with our existing themes. And so it was wildly successful. We had almost 1,500 participants from around the world. 86 countries were represented in participation. And while most members were individual youth contributors, as you can see from the graph on the bottom right there, we had people teaming up to work together on various projects, and it was really fantastic to see all the apps that they came up with. And so here's some just high-level examples. So folks are playing around with topics like artificial intelligence and how do you deploy artificial intelligence in application, making it so that you could sort of provide accessible interfaces to the world for people who are hard of sight. And on the right here, you see, for example, an app that tried to make this idea of virtual pantries to try to connect folks who didn't have a lot of resources to folks who did, to try to distribute and share things as everything went out of whack in their lives. And we got some really great news coverage out of this. So it was covered by MIT News. Abby and the folks in the MIT News office did a great job writing an article up for us. We also had articles in Voice of America, and we were featured on CNN as well. Some of the applications that the students made, some wonderful pieces about their efforts and the problems they tried to address. And just to tie it all back together is, we're providing this service, but we're also doing a lot of really interesting research as well. And a lot of our research these days now is focused on artificial intelligence. We've already discussed some of the projects, such as the Amazon Alexa integration. You can see here some of the student work, master's level and PhD level theses that have come out of the App Inventor project. And we have a website available to you if you'd like to learn more with, I think, almost 100 publications now over the years. So it's a wonderful group to work with. And we're really trying to push the envelope of what's capable for young kids. So just to wrap up here, some key takeaways for y'all. App Inventor is really a worldwide platform, and our goal is to allow people to build meaningful applications that are going to affect their communities in a positive way. And it's, our main interest, of course, is young people, but really anyone who wants to build an application, maybe a grandparent wants to help their grandchild with studying for a class or something like that. The goal is to take a technology that has seemed so far away for so many people and really make it available to them in as easy a manner as possible so that they can take it and run with it. And now we're even looking at really complicated technologies like neural networks and packaging those in a way that's really accessible to someone who's 10 or 12 years old. And all of this really comes down to trying to put together a whole suite of educational resources, programs, and research to help drive that mission forward. So with that, we'll take questions.
If I could just end with one comment, Evan, before we start questions.
Absolutely.
So Evan's last point was, that we have a lot of resources available. I just want to give an example of a project that is on YouTube. So it is a tutorial that basically in 1 hour takes somebody with absolutely no experience with App Inventor. And at the end of the hour, that person becomes, somebody who can do cloud computing, be able to talk to the cloud, etc. And the project is called End Hunger Now App Project. And it basically is a way of connecting, restaurants who might have some extra food they want to get rid of to homeless shelters. And it's a way of sort of facilitating that. And it's an example of computational action. And I'm just listing this as an example, but if you go to our YouTube site, you'll see many, many examples of these type of resources.